Hello class, today what we're going to do is talk about triangle proportionality. What we're really talking about here is how parallel lines divide things into proportional pieces. Okay, so triangle proportionality theorem, what this says is if you have a line parallel to one side of a triangle that intersects the other two sides, then it divides the two sides proportionally. Okay, now obviously when we have this parallel line here, this is creating two similar triangles, right? Because these angles are going to be congruent because there's corresponding angles with parallel lines, so we've got angle-angle similarity. But what's good about this and what's different is that instead of saying that, okay, QR is proportional to TR because they're similar triangles, what this actually says is that QT and SU are proportional to TR and UR. So not only are the entire sides proportional here, but also these pieces of the sides are proportional. Right? And so that's useful finding little missing pieces instead of just finding the whole side. And the converse of the triangle proportionality theorem says that if this line divides these two sides into proportion, then this segment here must be parallel to the other side. All right, that's all that says. Okay, so let's take a look at this, do a couple examples here. So we have that segment QS is parallel to segment UT. We know that segment RS is 4, segment ST is 6, QU is 9. We're looking for segment RQ. We want to try to find this one. All right. Well, before, just using similar triangles, that would be a little bit hard because we don't know the length of this whole side, so it's hard to find if there's a proportion with it. And we can, but it's a little bit annoying because we have x in two different places in a proportion. It's not a big deal, but it's a little annoying. This lets us shortcut that. So we can just set it up as a proportion with these two sides here. So we have RS and ST equal to RQ and QU. And then all we do is plug in numbers for that, cross multiply and divide, and we end up with RQ equals 6. Right? And so that's not too bad, and that's actually pretty simple stuff. So what we're going to do is this one. I want you to do this one on your own. Work it out, find the length of YZ, pause the video, and then come back. Alright, let's see how you did. We get an answer of 315 over 11. If that's not what you got, well, let's see, how do we do that? First, we set up our proportion. So make sure you have your proportions set up. We have VW and WX, and we have YZ and XY. Plug in the numbers, and then you just cross multiply and divide. So 36 times 35 divided by 44. Okay. And it gives you 315 over 11. All right, so let's see what we got next here. Okay, so here we have a shoe rack. It gives us the lengths of some of these sides. Let's see here. BA is 33 centimeters, CB is 27, CD is 44, and DE is 25. How do we know with these measurements that this shoe rack is not parallel to the floor? Well, we can put them in a proportion, right? Because these, if it's parallel to the floor, then these should be proportional. So let's make some ratios. CD to DE is 44 over 25, and that doesn't simplify. CB to BA is 27 to 33, that simplifies to 9/11. And 45 25ths does not equal 9/11, so these must not be parallel. All right. So let's try this one. I want you to figure out, is segment PS parallel to segment QR? And apparently the Q got lost. This is point Q right here. All right, so pause the video, figure out if these two are parallel, and then come back. All right, let's see here. You should have said, yes, they are. Set up a proportion. So what we have here, we have 90 over 50, PN to QP. And 72 to 40, right there. and those are proportional. So let's see, this is divided by 10, quite obviously 9/5. Here, these are both divisible by 8. So again, 9/5. All right. Now this brings us to one more theorem. This is the 3 parallel lines theorem, because we're having 3 parallel lines. Now what this does is it has 3 parallel lines cut by 2 transversals, not just one. You have to have 2 transversals here. And this again sets up a proportion, just like what we had over here with the triangles. We had 2 parallel lines cut by 2 transversals, making a triangle. This basically does the exact same thing. What this says is, since we have these 3 parallel lines, it's going to cut these 2 transversals into proportional pieces. So UW to YW is proportional to VX and XZ. All right. So let's take a look. All right. In the triangle, angle 1, 2, and 3 are all congruent. GF is 120 yards, DE is 150, and CD is 300 yards. Okay, we want to find the distance HF. So we want to know how far is it from Main Street to South Street along this line here, because this distance, remember, is always a perpendicular line. Now, there are actually 2 different ways we could do this. So, first off, since these angles are all congruent, that means that our lines are all parallel, right? Because we have congruent corresponding angles. So, since we have these 3 parallel lines, we can do this with that 3 parallel lines theorem. So, set up a proportion. This piece, HG to GF, and CD over DE. So we're doing the big one over the little one and the big one over the little one. All right. Plug in our numbers and cross multiply and divide. We end up with 240. Now 240 is not the length that we're looking for. We're looking for the entire distance HF. 240 is just from H to G. And so then we can add that to the 120 we have here, segment addition postulate, right? And that gives us that HF is 360 yards from Main Street to South Main Street. Now, there is another way we can do this. That's what we're going to do right here. Instead of taking this, finding the pieces, what we can do is we can set up a proportion with the entire sides, right? Just like if this had been 2 similar triangles, okay? What this actually does, it cuts it into, makes it 2 similar quadrilaterals, trapezoids in this case, which are still going to be proportional, right? So we're going to use the entire thing, and we can do this actually using the entire thing and the pieces. So look at it like this. We have CE. We find the length of CE. Well, that's 300 and 150, so that's 450, and over DE, and the entire length of HF, which we don't know, and GF, which is 120. So when we set up our proportion, we have this, right? But we don't know what HF is. But still, we can just cross multiply and divide, and we end up with 360 for HF. So we can do this as a whole thing to a piece or piece to piece. Either way works. And so that's good. It gives us some options, different ways to do things. All right, last theorem. This is the triangle bisector theorem. And what this says is that if a ray bisects one angle of a triangle, then it's going to divide this third side, this opposite side here, in such a way that it's proportional to the other 2 sides. So AD and DB are proportional to AC and CB. All right. So here it's taking this piece to this piece, to this side to that side. Okay. So let's take a look at this. Here we have angle QPR congruent to angle RPS. So since these angles are congruent, that means that ray PR is bisecting the angle. And we want to find the length of RS. So we want to find the length of just this little piece right here. Now, what we have that's proportional, we have QR is proportional to RS, and QP proportional to PS. Now, the problem with this is that we don't know what QR is or RS is. We don't know either one. But what we do know is that the whole thing is 15. So we can use 15 minus X and plug that in for QR when we set up our proportion. Alright, so set up the proportion here, going to plug in, and QR is 15 minus X, and then RS is just X. Again, we're going to cross multiply, and then we solve for X. So we're going to move our 13X's over, divide by, what would that be, 20, and we end up with 9.75 for X. Right? And so that means that side RS has the segment RS has a length of 9.75 units. Not too bad. Alright, so here we go. Here are 4 problems for you all to work out. Some of these are using angle bisectors, proportionality. Some of these are using the 3 parallel lines. So I want you to pause the video, find the length of the segment up here, find the length of the measure of the variable down here, and let's see how you do. Alright, let's see how you did. There's our answers. Here we go. We've got 12 for BD. And this is just a nice little proportion right there. 16 to X to 40 to 30. Cross multiply and divide. Over here, 19.2. Again, just proportion, cross multiply and divide. Not a big deal. Down here, the proportion is a little bit trickier. This is 28. The proportion here is 14 over X and equals 24 over 48. Alright. So you need to make sure you have that set up right. And the last one, 4 square roots of 2. Again, 4 over 4 square roots of 2 and 4, well, they're the same. 4 over X would also be 4 over square roots of 2. And that is it. That's what all we have for these different proportionality theorems. The one that's trickiest really is the angles here. Remember, it's part to part, hole to hole. Part to part, hole to hole. That kind of helps, makes it a little bit bigger. Always make sure you do that. So, for example, if we wanted to find GM, not JM, GM, it would be 16 over 15, and then all of GM, whatever that is, over all of HN, so all of 33. Make sure you got to keep that separate. Keep that straight, otherwise it's really a pretty simple thing. Okay, and that is that. Hope it helps, and I will see you next time.